This topic is about finding the antiderivative of a function. In other words, to find the function that you need to differentiate to get the given function. This is also the same as integrating a function. We need to be able to integrate simple functions involving algebraic fractions, negative and fractional indices. So it says my curve is y is equal to f of x. The derivative function is f dash of x is equal to 4x minus 5. What could my curve be? So what we have is we want to find y which is equal to f of x. So we're trying to find y which is equal to f of x. So we know we're trying to find f of x, and we know what f dash of x is, which is equal to 4x minus 5. So what we do know is if we differentiate f of x, then we get f dash of x, which is 4x minus 5. So what we're trying to find is what do we need to differentiate to get 4x take away 5. And this process is the opposite of differentiation, and we call it integration, or we integrate. So if we know f dash of x and we want to find f of x, we always integrate it. And in this topic today is the same thing as finding the antiderivative. Okay, so what we need to think is the opposite of differentiation, basically. So what do I need to differentiate to get 4x? So I know, obviously, if I differentiate x squared, then I get, so I'm doing this via trial and error. So I know if I differentiate x squared, I get x. But if I differentiate x squared, I actually get 2x. Do I want a 2x? No, I want a 4x. So because I want double the answer, I need to put a 2 here. So if I differentiate 2x squared, I know I get 4x. So that's right. What do I need to differentiate now to get minus 5? So I know to get a constant, I need to differentiate x. Well, when I differentiate x, I get obviously just 1. But I want minus 5. So I need to differentiate minus 5x. Okay. So if I differentiate, this is obviously the answer that I've got via the opposite of differentiation. So if I differentiate this, I get 2x squared differentiates to 4x. Minus 5x differentiates to minus 5. So that is correct, which is what I wanted. But that's not the only answer. Let's look at the case if I had f of x is equal to 2x squared minus 5x plus 7. Imagine I have a plus 7 at the end as well. Now if I differentiate that, then the 2x squared differentiates to 4x. The minus 5x differentiates to minus 5. And the 7 differentiates to 0. So that also gives me the f dash of x that I wanted, which is 4x minus 5. Even if I differentiate 2x squared minus 5x take away 10, if I differentiate that, I still get 4x minus 5, because the minus 10 differentiates to nothing. So what I can notice is no matter what I have as a constant, so here I've got plus 0, obviously, plus 7 minus 10, they all differentiate to give me 4x minus 5. So there's always a constant. You can always add a constant and it won't change my f of x. So what I need to realize is my general term for my f of x will be 2x squared take away 5x plus a constant, because I don't know what this constant is. And then if I differentiate that, I know I get 4x minus 5. The plus c will differentiate to nothing anyway. Now, if I wanted to be more specific and find what this constant is, then I need to know what it goes through, a point that it goes through. So if I know that if f of x, if y is equal to f of x passes through, let's say, 3, negative 1, then that means because f of x is equal to 2x squared minus 5x plus c, I can substitute the point 3 minus 1 into this. So remember, f of x is just y. So minus y will be equal to 2 times 3 squared minus 5 times 3 plus c, which means minus 1 will be equal to 2 times 3 squared is 18, take away 15, which is 3, plus c, which means c will be equal to negative 4. So now I can get my answer. Therefore, f of x will be equal to 2x squared minus 5x take away 4. So that means if I don't know a point that it goes through, I need to write the general answer, which has a plus c in it. But if I know that it goes through a point, then I need to substitute and find the actual function. So there's two different methods depending on what you're given. So at the moment, we're thinking of integration or antiderivative as the opposite of differentiating. So it says, first question using this method is find the antiderivative of f dash of x is equal to x cubed minus 3 over 2 x to the minus half minus 6x to the minus 2. So I'm going to do this by trial and error. So the first term has x cubed, so I need to, because I'm doing the opposite of differentiation, I need to increase the power, so x to the power of 4. But when I differentiate x to the power of 4, I get 4x cubed. I don't want 4x cubed, I want the x cubed here, just 1x cubed, so I need to divide by 4. So I get a quarter x to the power of 4. Okay, second term, I've got my x to the minus half, which means if I'm doing the opposite of differentiation, I need to increase the power. So x to the power of half. Now, when I differentiate that, I get half x to the minus half. I don't want half x to the minus half. I want minus 3 over 2. So I need to multiply that by minus 3 over 2. Multiply it by minus 3. Okay, the last term, I've got x to the minus 2 there. If I increase the power, I get x to the minus 1. When I differentiate that, I get minus x to the minus 2. But I don't want minus x to the minus 2. I want minus 6x to the minus 2. So I need to times it by positive 6 plus the constant. So this is how you do this via the opposite of antiderivative, finding the antiderivative using the opposite operation, opposite to differentiation. So let's look at another example via trial and error, and then I'll give you a formula to use. Okay, so here again, f of x will be equal to x to the minus 2. If I increase the power, I get x to the minus 1. When I differentiate, it might help if I write the differentiate. So if I do d dx of x to the minus 1, I get minus x to the minus 2. But if I look here, I want a positive 3, which means I need to multiply this by negative 3. So that means I need to multiply this by negative 3. Okay, second term, I've got x to the power of a half. If I increase the power, I get x to the power of 3 over 2. If I differentiate this term, so d dx of x to the power of 3 over 2 is equal to 3 over 2x to the power of a half. But I didn't want 3 over 2. I wanted a 6 at the front. So a 6 at the front, which means I need to times this by 4. So it's a plus 4. Okay. Next term is x to the power of 1. So if I increase the power, I get x squared. So if I do d dx of x squared, I get 2x. Do I want a 2x? No, I just want a 1x. So I need to times this by a half, which means I need to times this by a half. The last term is minus 4. That one's quite easy. I know that's the antiderivative of minus 4 is minus 4x, and then there's a plus c. Okay, next example. The curve C with the equation y is equal to f of x passes through the point 4,5. So that means I'm going to have to find a specific function. Given that f dash of x is equal to x squared minus 2 all over root x, find the equation of C. So we have f dash of x is equal to x squared minus 2 over root x, which is the same thing as if I separate the numerator out, x squared over root x minus 2 over root x. X squared over root x is the same thing as x squared, x to the power of 2 take away a half, which is the same as x to the power of 3 over 2. Minus there, 2 times 2 over root x is 2x to the power of minus a half. Okay, so that means, so this is f dash of x. Okay, so I need to now find f of x. So remember, it's the antiderivative, so the opposite. So I need to first increase the power, which is x to the power of 5 over 2. So if I do d dx of x to the power of 5 over 2, I get 5 over 2 x to the power of 3 over 2. But I don't want the 5 over 2, which means I need to times by 2 over 5 to get rid of it. So that must be 2 over 5 at the front there. The second term is minus 2x to the minus a half. So that means when I integrate it or find the antiderivative, I need to increase the power, which is to the power of a half. If I do d dx of x to the power of a half, I get half x to the minus a half. But I didn't want half, I want minus 2. So I need to times this by minus 4. Okay, because half times minus 4 would give me minus 2. So it'd be minus 4. And then plus the c. Don't forget to plus c always. Okay, now I need to substitute the 0.45 into f of x, which means I get 5 is equal to 2 over 5 times 4 to the power of 5 over 2 minus 4 times 4 to the power of a half plus c. 5 is equal to 2 over 5. 4 to the power of 5 over 2 is the same thing as square root of 4, which is 2, to the power of 5, which is 32. 2, 4, 8, 16, 32, yep. And minus 4 times 4 to the power of a half is just 2 plus c. So 5 will be equal to 32 divided by 5 is 6.4 times by 2 is 12.8, take away 8 plus c, which means 5 is equal to 12.8 take away 8 is 4.8 plus c, which means c is equal to 0.2. So if I rewrite f of x is equal to 2 over 5x to the power of 5 over 2 minus 4x to the power of a half plus 0.2 is the same thing as plus a fifth. Okay. Now all this time we're doing it via trial and error. So just, not trial and error, but reverse differentiation. So now what you have to realize is you can write it as a formula. So the formula for finding the antiderivative or finding the integrating is, if you know dy dx is x to the power of n, y must be an increase in the power, so x to the power of n plus 1, but then you have to divide by the power as well. So divide by the power as well, because obviously when you differentiate x to the power of n plus 1, you get n plus 1. That comes down, so that's why you have to get rid of it. Now the key thing here is n is not equal to minus 1, because when n is equal to negative 1, the denominator is 0, therefore undefined. So we can't use it when n is equal to minus 1. Similarly, if f dash of x is equal to x to the power of n, then f of x is equal to 1 over n plus 1, x to the power of n plus 1 plus c. N is not, again, equal to minus 1. So e.g., if you have, I don't know, f dash of x is equal to 5x cubed plus 3x to the power of a half, then f of x will be, the 5 remains there, you increase the power, so x to the power of 4, and you divide by that increase, okay? So 3, x to the power of half, you increase the power, which is 3 over 2, and then you divide by that increase. So whatever you increase it by here, you divide by that increase as well, okay? And plus c, and then you just simplify. So f of x will be equal to 5 over 4x to the power of 4. 3 over 3 over 2 is the same thing as 3 times 2 over 3, which means it just cancels out, which is 2x to the power of 3 over 2 plus c. Okay, find the original curve y is equal to f of x when f dash of x are each of these, okay? Now in these cases, we can use the formula straight away, so I'm just going to apply the formula. So first one is f dash, let's just call it a, b, c, d. So a is f dash of x is equal to 12x plus 3 over 2x to the minus 3 over 2 plus 5. So f of x will be equal to increase the power, so x to the power of 1 because x to the power of 2, divide by the increase, plus 3 over 2, x to the power of increase the power, which is minus a half, divide by the increase, which is minus a half, plus 5x to the power of 1, this is x to the power of 0, over 1 plus c. If I simplify this now, 12 divided by 2 gives me 6x squared. 3 over 2 divided by minus a half gives me minus 3. Because the 2's cancel out, so I'm just left with minus 3. X to the minus a half. Plus 5x plus c. Okay, let's go on. We want to B now. So B is equal to f dash of x is equal to half x to the minus a half x to the minus 3 over 2. So if I'm trying to work out f of x is equal to increase the power, which is, so keep the half there, increase the power, which is a half, divide by a half, minus x half, increase the power, which is a minus a half, divide by minus a half, plus the c. So f of x will be equal to half over half, just gives me 1, so it's just x to the power of a half, minus a half divided by minus a half, just 1, so x to the minus a half, plus c. Okay, next one is C. So f dash of x is equal to 2x to the minus a third plus 4x to the minus 5 over 3. So f of x is 2x, increase the power, so add 1 to it. Be very careful, minus a third plus 1 is 2 over 3, so over 2 over 3. Plus 4x, increase the power by 1, minus 5 over 3 plus 1 is minus 2 over 3. A lot of people make mistakes there, so make sure you add 1 correctly, plus the c. Now I just need to simplify. 2 over 2 over 3 is the same thing as 6 over 2, which is 3, x to the 3 over 2 over 3. And then we've got plus 4 divided by minus 2 over 3 is the same thing as 4 times 3, which is minus, so 12 divided by minus 2 is minus 6, x to the minus 2 over 3 plus c. Okay, D. F dash of x is equal to x squared plus x to the minus 2 plus x to the power of a half. So f of x will be increase the power, so x to the power 3 divided by the increase, plus x to the minus 1 divided by the increase. And last term is increase the power still, so plus x to the power of 3 over 2 over 3 over 2 plus c. So when we simplify this, I get a third x cubed minus x to the minus 1 plus 1 over 3 over 2 gives you 2 over 3. So it's 2 over 3 x to the power of 3 over 2 plus c. Okay, next question. Work out the equation of the curve which passes through the given point and has the following gradient function. Okay, a, b, and c. Okay, for a, we've got dy dx. We're using a different notation. 3 over root x minus x. Okay, so dy dx is, if I had to write it in index form, so always with our calculus, try to write it in index form first. Same thing as 3x to the power of minus a half, because root x is in the denominator. Take away x. Okay, if you're finding y, so you're finding the antiderivative, so you need to increase the power. So 3x minus half increased by 1 is positive half, divide by positive half, minus x increased the power is 2 over 2 plus c. So y will be equal to 3 divided by half is the same thing as 3 times 2, which is 6x to the power of half, minus a half x squared plus c. Okay, so I need to substitute now. So substitute the point 4, 0 into y is equal to 6x to the power of a half minus a half x squared plus c. So I get 0. I get 0 is equal to 6 times 4 to the power of a half minus a half times 4 squared plus c, which means 0 is equal to 6 times 2, which is 12. 4 squared is just 16. 16 divided by 2 is 8. 12 minus 8 plus c, which means 0 is equal to 4 plus c, which means c is equal to minus 4. Okay, so y can be rewritten as 6x to the power of a half minus a half x squared, take away 4. And that would be your answer for part A. Let's go here for part B. So part B is dy dx is equal to x plus 2 squared, which is, if expanded, you get x squared plus 4x plus 4. So that means y is, find the antiderivative, so increase the power, divide by the increase. increase the x to the power of 1 to x squared, divide by 2, the increase, and the last term is 4x to the power of 1, divide by 1, plus c. All you need to do is simplify it, which gives me a third x cubed. 4 divided by 2 is 2x squared, plus 4x plus c. I need to substitute the point that I know, which is 1, 7, into y is equal to a third x cubed plus 2x squared plus 4x plus c to find my c, which means 7 is equal to a third times 1 cubed plus 2 times 1 squared plus 4 times 1 plus c, which means 7 is equal to a third plus 2 plus 4, which is 6 and a third, plus c, which means c is equal to 2/3. So if I rewrite it, y is equal to a third x cubed plus 2x squared plus 4x plus 2/3. Okay, let's go to c now. Okay, c is dy dx is equal to x squared plus 3 over root x, which is the same thing as x squared over root x plus 3 over root x, which is the same thing as x to the power of 2 take away a half, which is 3 over 2, plus 3 x to the minus a half. So when we're finding y, we need to increase the power, x to the power of 5 over 2 divided by that increase, plus 3x to the power of increase the power by 1/2, divide by that increase, plus c, which means y is equal to 2 over 5 x to the power of 5 over 2 plus 6x to the power of a half plus c. I need to substitute the point that we know, so 0, 1, into y is equal to 2 over 5 x to the power of 5 over 2 plus 6x to the power of a half plus c, which means I get 1 is equal to 2 over 5 times 0 to the power of 5 over 2 plus 6 times 0 to the power of a half plus c. So if I do that right, I get 1 is equal to c. Therefore, y is equal to 2 over 5 x to the power of 5 over 2 plus 6x to the power of a half plus 1. That's my final answer there. That's my final answer there. Okay, next question. The curve C with the equation y is equal to f of x passes to the point 1, 2, and f dash of x is equal to 2x cubed minus 1 over x squared. Find the equation of C in the form y is equal to f of x. Okay, so I've got f dash of x. I've got f dash of x is equal to 2x cubed minus 1 over x squared can be written as minus x to the minus 2. So f of x, which is the antiderivative, is increase the power of x by 1, so it becomes x to the power of 4, divide by that increase, and increase the power of my x to minus 2 by 1, so x to minus 1 over that increase plus c, which means f of x is equal to 2 over 4 is just a half x to the power of 4, minus over minus 1 gives you positive x to the minus 1 plus c. So we're substituting 1, 2 into f of x is equal to half x to the power of 4 plus x to the minus 1 plus c. So I get 2 is equal to half times 1 to the power of 4 plus 1 to the power of minus 1 plus c, which is 2 is equal to half plus 1, which is 3 over 2. 3 over 2 plus c, which means c is equal to just a half. 2 take away 3 over 2 is just a half. So that means f of x is equal to half x to the power of 4 plus x to the power of minus 1 plus a half. The gradient of a particular curve is given by dy dx is equal to root x plus 3 over x squared. Given that the curve passes through the point 9, 0, find the equation of the curve. So we've got dy dx is equal to root x. So separate out the numerator. Plus 3 over x squared, which can be rewritten as x to the power of root x is half, take away 2, which is minus 3 over 2, plus 3x to the power of minus 2. So y will be, find the antiderivative, so increase the power by 1, so I get minus a half over minus a half, plus 3x to the power of increase the power of x by 1, divide by that increase plus c. So y would be equal to 1 over minus a half is minus 2, so just flip the fraction in the denominator over. So I get minus 2x, minus 2 times x to the minus a half, minus 3x to the power of minus 1 plus c. I need to substitute 9, 0 into y is equal to minus 2x to the minus a half, minus 3x to minus 1 plus c. So 0 is equal to minus 2 times 9 to the power of minus half. Minus 3 times 9 to the minus 1 plus c. So 0 is equal to 9 to the power of minus a half is just 1 over 3. So minus 2 over 3 becomes the first term. 9 to the minus 1 is 1 over 9. Minus 3 over 9 is minus a third. Plus c, so 0 is equal to minus 1 plus c, which means c is equal to 1. Therefore, I can write y is equal to minus 2x to the minus a half, minus 3x to the minus 1 plus 1. Okay, the curve C with the equation y equals f of x is such that dy dx is equal to k minus x to the minus a half, where k is a constant. X has to be greater than 0. Given that C passes the point 1, minus 2, and 4, 5, find the value of k. Okay, so first I've got dy. If I know the points that it goes to, I need to find y first. So dy dx is equal to k minus x to the minus half. So I need to find the antiderivative of that. So k is kx to the power of 0. So if I increase the power by 1 and divide by that increase, if I increase the power of x to the minus a half by 1, I get x to the power of a half and divide by a half plus c. So y is equal to kx minus 2x to the power of a half plus c. Okay, so I need to first substitute 1 minus 2 into y is equal to kx minus 2x to the power of a half plus c. So I get minus 2 is equal to k times 1 minus 2 times 1 to the power of a half plus c, which means minus 2 is equal to k minus 2 plus c. So if I cross it out, I've got k plus c, k plus c equals 0. So that is equation 1. Okay, if I substitute the equation, the point 45 into y is equal to kx minus 2x to the power of a half plus c, I get 5 is equal to k times 4 minus 2 times 4 to the power of a half plus c, which means 5 is equal to 4k minus 2 times 2 is minus 4 plus c, which means 4k plus c is equal to 5 plus 4, which is 9. So this is 2. So if you look at both this equation, I've got a plus c on the right hand side, so I can do 2 take away 1. If I do 2 take away 1, I've got 0. I get 9 take away 0, which is 9. 9 take away 0 is 9 on the left hand side. 9. 4k take away k gives me 3k, and c take away c gives me nothing. So I've eliminated c. So k must be equal to 9 divided by 3, which is 3. And we were asked to find k. I might as well find c, since I've found k. So since 9 0 is equal to k plus c, and 0 is equal to 3 plus c, which implies c is equal to minus 3. Okay, so what's B? Show that the normal to C at the point 1 minus 2 has the equation x plus 2y plus 3 is equal to 0. So if I rewrite the y is equal to, k was 3, so it's 3x minus 2x to the power of a half, take away 3, that's my y. If I'm trying to find the normal, I need to differentiate to find my gradient for my tangent, yeah? So that's my y. So I need to find dy dx, which is given to me really. It's just k minus 3. So it was k minus x to the minus a half, which is the same thing as 3 minus x to the minus a half, because we know k is 3. So if I want to find the dy dx at the point x is equal to, because it's 1 minus 2, x is equal to 1. All I need to do is substitute 1 into dy dx. So 3 minus 1 to the power of minus a half, which is just 3 take away 1, which is equal to 2. Now this is my gradient of my tangent, don't forget, yeah? So my gradient of my normal, so I'll have to go here. Gradient of normal is my negative reciprocal of my gradient of my tangent, which is going to be equal to negative 1 over 2. Okay, and now using y minus y1 is equal to m times x minus x1, where m is equal to negative half, which is the gradient of the normal, and my point x1, y1 is equal to the point I was given, which is 1 minus 2. I get y plus, my y minus minus 2, which is y plus 2, is equal to m, which is minus a half, times x minus 1. So y plus 2 is equal to minus a half x plus a half. If I multiply everything by 2, I get 2y plus 4 is equal to minus x plus 1. All I need to do is clean this up, take everything to the left-hand side, so negative x becomes positive x plus 2y x plus 2y, 4 take away 1 is plus 3, which is equal to 0, which is what I wanted. Okay, a thing about notation. So when obviously normally we have y is equal to f of x, what we need to know is the capital f of x is the antiderivative. So when you do integrate a function, you get capital f of x. So capital F of x is the antiderivative of f of x. So when we integrate something, when we find the antiderivative, we find integrating something, and we normally write it like this. So integrate means f of x means you integrate. So integrate is this sign, which we'll go through in the next lesson, next topic. So integral of f of x dx. Okay, so this is integral. So integral, which means integrate or find antiderivative. Okay, so if we have f of x, which is the original function that we're given, then if we differentiate this, then we get f dash of x. Okay, but if we integrate, so if we do integrate f dash of x, then we get f of x. Okay, and if we integrate f of x, so if we integrate f of x, then we get capital F of x. If we differentiate capital F of x, we go back to y is equal to f of x. It's just a word about notation, be very careful. So if we start off with f of x, if we differentiate it, we get f dash of x, but if we integrate it, we get capital F of x.